Hi, in today's video I'm going to be talking about ffmpeg scene detection and how we can run one command and analyze a video and chop it into little clips based on changes in the scene in the video. So in previous videos what I've done is shown you a couple of scripts I'd written called scene detect, scene clip and scene cut, and what they do is they analyze the video and create a list of all the timestamps of the scene changes, and then the second script, scene time, changes that into a format ffmpeg can use, and finally the third script, ffmpeg scene cut, cuts the video into the clips. So basically, to perform scene detection, what we've got is 3 scripts to do the job. And you may be asking, why didn't I just write one script? And there's a good reason for that, and that's because they each have their own tasks, and I wanted them to perform that task well and not to try and do everything. So it also allows you to be more flexible. But what I want to do is automate the process so that I can just run one command and chop the video up into multiple chunks. What I'm going to do first of all is come across and come into this directory where I've got a copy of Big Buck Bunny. And what I'm going to do is show you the process at the moment, running the 3 scripts one after another. So first of all, what we do is we run scene detect, and we'll run that with the -H option, which gives us the options we can use with this script. So what I'm going to be doing is doing scene detection on just 1 minute of the video to actually speed up the process. So what I'm going to do is run scene detect -S, and what this is going to do is perform scene detection from the beginning of the video. I'm going to give it the video name, and what we're going to do is specify the amount of seconds after the start time that we want to perform scene detection for. So I want to do a minute. So this is what I'm going to do. Specify a minute, and we can give this an out file name, so detect.txt. And what that's going to do is it's going to run ffmpeg and analyze the video and create a text file called detect here, so bat detect, and what you'll see here is a list of timestamps of the changes in the scenes in the video. But this format can't be used by ffmpeg directly, so what we have to do is use another script called scene time to convert this into a format ffmpeg can use. So what we do is run scene time. Okay, we give it the input, which is the detect file, and the out file we'll call cutlist. Okay, cutlist.txt. So what that's done is created a file like this, where what we have is a start time and a duration for the clip. So this is a format ffmpeg can now understand. We can say seek to the beginning of the video and then create a clip for 11.875 seconds. Yeah. So the final script is called scene detect, scene cut rather. So what we do is we give it the input file, which is the video, and the cut file we just created. So scene cut, give it the input file, Big Buck Bunny, C, cut list. And what it's doing now is it's using a loop to go over that cut list and create all the files. It's going to go through and cut the video up into chunks based on the scene changes. So there we go. What you can see here is all the clips. So what I'll do is I'll open this up, and as you can see here, these are all the little clips. So these are all the scene changes. Okay, so that's the process that we actually have to go through. And what I wanted to do was actually make that easier. So what I'm going to do is get rid of all the text files, and let me just manually get rid of the clips I've created. Hang on, fuck off. Right, there we go. Okay, so what I'm going to do now is show you how we can make this easier. Okay, so let me just open this up. I'm going to switch to Emacs here, sorry about this. Big Butt Bunny, Makefile, Right, so what we're going to do is automate this process. So instead of running 3 scripts one after the other, what we're going to do is create a wrapper, another sort of script, as it were, to run them all. But what we're going to be doing is using a Makefile. And the reason for this is because it's got some nice features that we can actually use for automation. So these are the notes at the top here. So move this Makefile into the same video directory as the video process. Right, we've done that. So what you need to do is tell the Makefile the name of the video to process, either by editing the Makefile and changing input.mp4 to the name of the video to process, and then running make. So that's this section down here. So what we can do is just, I've got a default placeholder here called input.mp4, and we just need to change that to the name of the file that we want to process, and then run make on the command line. We can also override this variable on the command line by running make input equals and then the file name that we want to process for scene detection. And the final note down here is make clean. This will prompt you to remove the text file and the video clips except the input file. So what this will basically do is allow you to clean the directory of everything. So you can just run make clean. It will remove the scene detection and text files and all the clips that you created. So let's go and have a look at how this works. So let's switch back to the terminal. We've got a file in here called bbb.mp4. So what we'll do is just change this to bbb. If I can type bbb mp4. Come into here, just type make. Okay, it's analyzing the video. It's going to create the text files. Now you can see it's chopping it up. We've automated the whole process, so instead of typing 3 commands, we just type make. There's all the clips. So we've done the same thing, but with a lot less typing. So what I'm going to do is do that again, and let me just switch back to file I've got open here. So I'll just change that back to input mp4, and then what I will do is override it on the command line. So I want to get rid of these 2 files there. Okay, so there we go. So what we've got here is the Makefile and the bbb.input file, and if I come back to the Makefile, you can see here the variable input is equal to input mp4. So I haven't got a file called input mp4 in the directory, so if I run make, it's going to throw an error. So as I said, you can either change the Makefile and put the file name in there, or you can override it on the command line by running make. Just start typing input, press tab, and you can see it's going to auto-complete to input with the equals, and you're also going to get auto-completion for the file name. So I've got a file here called bbb.mp4, b tab, press return, we're over in the variable, and it's analyzing that video. Okay, you can see it's created all clips. So now what I'm going to do is I want to get rid of all the clips that I've created and these files. So what I want to do is delete So the way the scene detection works is what it does is it takes the original file name and removes the extension and creates new files called -1, -2, -3, so on for each clip. So what we know is to remove those, we just need to match the -1, dash number.mp4. So if I run make clean, if I come down here, what we got is this option called clean, and what that's going to do is it's going to prompt us to remove the cut list, the detection file, and all the clips we created. So I'll go through the Makefile and explain all this code in a second, but I'll just show you how it works in practice. So I just type make clean. You can see what it's doing now is it's actually printing out the command it's going to run. So we've got RM, F, and I. So F basically ignores errors. So if you specify a file delete that's not there, it's not going to complain. And the -I gives us this prompt to type yes or no as where we want to delete these files. A lowercase I will prompt you for every file. An uppercase I just gives you one prompt to remove all the files. So I want to remove all these files, just type Y. As you can see, we've now cleaned the directory and we just got the make file and the video there. So you just come back here. So what I should have mentioned is in the script, what I was doing here is to, as I showed you on the command line, using the scene detect script, you can either analyze the whole video or you can use the -S and E options to specify a start time and an end time for the ffmpeg scene detection. So in the script here, what I had was those options, so that only did scene detection for like 20 seconds. So what I'll do here is I'll just change this and put this to a minute. And what I'll do is copy this to Elephant's Dream. So this is Elephant's Dream, which is another video that was created on Blender, I think over 10 years ago. Open source, public domain. And what I'm going to do is do scene detection on this video as well. So I've copied the make file in here, and just as a side note, what I've done is I've put this on the repository for these scripts. So what you'll see here is Makefile scene detection, Makefile, and this is the Makefile that I'm showing you here. Without the options, I haven't specified the options for a start time and end time. This is just going to do scene detection for the whole video, but you can just modify the script if you want to set a start and end time. So that's the script. What I'll do here is, as I said, just to speed things up, I'm just going to analyze 1 minute of the video. So Elephant's Dream, there we go, there's the Makefile. And again, what you need to do is either change the input.mp4 to the name of the file you want to process, but let's say you don't have to do that, you can just override it on the command line. So drop the make file in there, just run make, type in, tab, input, Elephant Stream, tab, job done. So instead of going through running one script, creating a file, running another script, taking that input, and then running a third script, we can just do this and have more time for drinking tea. So as you can see there, it's just going through the script, and we've got all the clips there. And as you can see, the original script is elephantstream.mkv, and it creates all the clips 1, 2, 3, 4, 5, 6, 7. And we've got the cut list and the detection down here. So what I'm going to do now is actually go through the Makefile and show you how this all works. So this is, sorry about this, zooming in and out. Right. Okay, so this is the help text, basically, move this text Makefile into the same directory as the video to process. Again, edit the Makefile and change input.mp4 to the name of the file to process, and then run make. Or don't edit the file and just run make input equals and give it the file name. And then when you want to clean everything, just type make clean. It's going to give you a prompt to remove all the text files and the video clips that you created, and it will remove them. So first of all, we've got this variable input equals input.mp4, and this is just so we've got a base file name here that we can override. You can also do stuff like run wildcards and search for like all MP4s, but the issue with that is because we're creating a we're taking an MP4 video and we're chopping it up into lots of other MP4s. We don't want it to like search for an MP4 and then find, chop it up and then run it over and over again. So that's why we're not using a wildcard there. Then what we've got down here is all. So you can run make all, and it's the same thing as running make. And what this does is this runs the third step, cut. So we've got 3 steps here: detect, time, and cut. So what that does is basically says, yeah, we want to run the third step, and each of these steps depends on another step. So what you can see here is detect. What we have here is we have the target, and then we have the prerequisite, and then the recipe. So this is the target, and the prerequisite for this target is this input here. So to run this first thing, we need input, which is going to be the video. Yeah. Then what we have is we have this little dollar. You can see this little @ sign. What this does is this hides the command from being printed in the terminal. For instance, if you were to run a recipe that just said echo hello, what it would do is actually print out the command echo hello and then hello. So by prefixing a command with this @ sign, what it will do is actually it will run the command, but actually it won't print the command in the terminal. So what we have here is the scene detect, and I say these are the options for start and end times, and I'll just remove these because by default I haven't set them in the actual Makefile. Hang on. Okay, so scene detect, it takes the input, which is the video, and it gives and we've got an output, and it's creating a file called detection.txt. Very simple. The next one down here is scene time. This is the next thing, and you can see here the target is called time and the prerequisite is detect. So this target here, time, depends on detect, which is this thing here. So basically it's going to run these in order. So detect depends on the input, then time depends on detect, and we run scene time, give it the detection file, and then create the cut list. And finally, the third script that we're running is the scene cut script, and you can see that depends on time. So cut depends on time. So up here we say all runs cut, so it goes to cut and then it says okay, cut depends on time, time depends on detect, detect depends on input. So what it's going to do is it's going to take the input, run detect, run time, and then run cut. So scene cut, we get the video file and the cut list. So basically what it's doing, it's doing all those steps for us. We're just automating the process. So instead of typing these 3 commands out by hand, we can just type out a couple of letters, press return, and the job's done. And it's like more time for drinking tea. So this little bit down here, this clean, what we have here is something that says phony clean, and then clean, and then this command here to remove the files. So let me explain this. Again, this is the target clean. So when we run make clean, it's going to run this recipe, and it's going to run rm-f, ignore errors, capital I, prompt you to delete all the files, and it's going to prompt to delete the cut list, the detection. And you can see here what we've got is wildcard. When you're using Makefiles, instead of using just a asterisk as a wildcard, you have to use this special sort of notation of wildcard. And then what we're doing is searching for something asterisk -0 to 9 repeated.mp4, which is what we append to all the clips we create. So this phony thing here where it says .phony clean, what that does is if you had a file called clean in the directory and you run make, if you didn't add this phony clean thing here, what would happen is it would actually run this command. So to get around that, what we do is we have this thing here where it says, okay, you know, it's not really a file called clean. So if you find a file called clean, don't run this command. It's only if we explicitly run make clean will it actually run this command and prompt you to delete the text files and the clips that we created. But again, it's not going to prompt you to delete the original input file. So that's the gubbins of the Makefile. Again, there's the bump at the top explaining how to use it. Got the input, and again, this is running all. So we run the cut, got the detection script, we've got the time script, we've got the scene cut, and then we've got clean. So that's it. So we've got elephant stream. So if I want to clean this up, just type make clean, remove all that, yep. And we just got the Makefile. So if I want to do the scene detection again, I'll do it with Big Buck Bunny because I think it's, let me just see how long elephant stream is. 10 minutes. Yeah, let's just do elephant stream. So what I'm going to do, I'll do scene detection on elephant stream, the whole video, just by running make input equals. So again, if I just run make, you can see it's going to give me an error. No rule to make target input.mp4 needed by detect. Stop. And again, that's because we haven't changed name. So again, we could change the name here, but it's easier just to go make input equals elephant stream, bang, and just leave it. What it's going to do, it's using ffmpeg now. It's analyzing the whole video and all the scene changes. And then what you can see is it's now kicking into the stage where it's creating the clips. So it goes through, it performs the scene detection, creates the detection file. It then runs the scene time script, which converts that into a format ffmpeg can use. And finally, we run the scene cut script, which loops over all the timestamps, seeks into the video and chops it up to the millisecond. So this is how we can have more time for drinking tea and eating biscuits instead of typing out commands in the terminal. So you can see it's giving us the sort of timestamps where it's sort of processing. And also just give you an idea of how long it takes to process a sort of 10-minute movie. And the other thing I wanted to mention, there's an advantage to using a Makefile, is if I run make again after I've done this, Makefile works on the modification times of files. So what happens is it's going to see that all the files have already been created, so it doesn't process them all again. It will run the first part of the script again. If I run like make input equals elephant stream, it will run the ffmpeg scene detection part. But once it gets to chopping it up, it's going to see that all the files are already there and it's not going to do it again. So that's another advantage of make, is it's got lots of functionality that we can use to our advantage. Another really good example of that is the clean function. You know, of course, you could just write a script you know, a wrapper script that runs these scripts one after another. But the advantage of using a Makefile is, say, it's got these things like clean built in that we can basically use to, you know, remove all the clips if we don't, you know, we don't want them. That may be the case you're going through sort of chopping up lots of videos. There are video editors that have got scene detection in them. For example, the best video editor, free video editor on Linux, Mac, and Windows is DaVinci Resolve. But the issue is on Linux, it's got no support for H.264 or AAC codecs, so you can't import or export H.264. So you've got to convert it to DNX, which increases the file size by 10 times. So you've got a gig video and you convert it from H.264 to DNX. It increases 10 times to 10 gig. So that's why using ffmpeg to do this scene detection is an advantage, because especially on Linux, you don't have an easy way to actually chop up H.264 video. So here's all the clips. As you can see, I've got all the clips. So what happens if I run let me just run make input elephant stream again. Show you what happens. It's going to go through and it's going to analyze the video again, but then it's going to stop. Okay, stopped. And the reason for that, because the job's done. It can see from the modification dates and stuff, the job's done. I don't need to recreate all this stuff. So there you go, there's all the clips. You can see all sequentially numbered. So if I come out into here, Elephant's Dream, and I actually showed you on a video with Emacs about how you can get this file listing, so that as you can see, if I just switch back down, let's switch back here. So as you can see in the terminal, when I list the files with the list command, they're listed 1, 10, 11, 12, 13, 14, which is out of order. I mean, literally out of order and out of order. Whereas if I'm looking at these in Emacs, you can see these are listed in the correct order. So while I'm just thinking about that, I will show you my Emacs file and the list command, so that you can actually list files in this order in the terminal. So .config emacs init.el. See if I can remember where the thing is. Bear with me for this, but it's just something that's really irritating. I know I've got it somewhere. I should really just search for list, really. Where was it? It's one of these things, is it? Oh yeah, listing switches. That's it. AHLV. That's it. Okay, just bear with me. I'm getting there. Okay, so just LS or LSL. You can see they're all out of order. Yeah. I type LS. There we go. Now they're all in order. 1, 2, 3, 4, 5, 6, 7. So LS-AHLV, and that's going to put them in the correct order. So that's just something that really bugs me about listing files sometimes, and there's a way around it with the couple of options for the list command. So hang on. All right. So that was the script. What am I looking for? Okay, so those were all the files. So again, as I showed you, if I just ran make input equals elephant stream again, it doesn't process them all again. And just to get rid of all these, I'll just type make clean. Want to remove all these files? Yep, I do. Sure do. Bang. And you can see we've still got the make file and the original file untouched. So that's another really nice feature that you might go through and you looking at videos to process, chop up, to reuse, repurpose. or extract something, and you think, oh no, there's nothing in that. There's no clips there I actually want to do. I mean, you could, come to the terminal, type RM. See, the other issue is, suppose this was called elephantstream.mp4, and you got a load of MP4 clips, and you suddenly, it's easy to do. What you'll do is you do rm.mp4 to remove all the clips, and then suddenly realize, oh shit, I've just deleted the input file as well. So that's why using the clean option will actually prompt you, do you want to delete all these files? You can check that, it's not deleting anything you don't want to. And, just press yes, and it's going to get rid of all the stuff. I've written the regular expression so that it should only match the created clips and not the original file. So that's how we run Elephant Stream. Let's just come back to Big Buck Bunny again. Big Buck Bunny. What I'll do is let's do same detection on Big Buck Bunny. Just remove this section. So again, quick recap. You can either change this to bbb.mp4, whatever the file name is. You come down to the scene detection part, and you can specify a start and end time for the detection if you want. Basically, all you got to do, stick the Makefile in the directory, come across to the terminal. If you haven't edited the Makefile, just make input equals that, return. You're getting auto completion for this as well. So I'm just typing make tab in tab equals, type name and start typing the file name and tab it. So it couldn't be quicker. Much faster than writing out 3 commands. Nothing wrong with the scripts. The scripts are fine. I mean, I wrote them that way for a reason, because they all have individual functions, and it's just a Unix way of doing things to have something that does one job well. So scene detect does the detection on the video. Scene time converts it into that format I showed you, where you have a start time and a duration for the clip, and then scene cut does the job of actually taking the cut list, looping through it, and basically cutting up the video. So you can see here it's cutting up Big Buck Bunny. Let me just finish the tea. Yorkshire Gold. That's my brand. So I say this is a big improvement on running the scripts individually. It just means you can take the Makefile, stick it in the directory, make input equals file name, press return, job done. That's it. And it's going to, sit there, automate everything for you, chop up all the clips, name them sequentially. If you don't like what you've done, just run make clean and delete them all, and then move on to another video. So I said the advantage of this is video editors like DaVinci Resolve on Linux got no support for H.264 AAC. It's not even got support for the AAC codec in the paid version on Linux. So all the other video editors on Linux are terrible. Blender, some people talk about using Blender. Oh, it's painful to edit videos with Blender. I've tried it. And most of the other ones are just clunky with terrible interfaces. So actually doing this on the command line has got lots of advantages, and you can see there it's already done. So that's chopped up 10 minutes of Big Buck Bunny just by running make input equals bbb.mp4. No typing multiple commands. If I come across here, Big Buck Bunny, again, we've got all the files listed one after another. You get the idea. So it's chopped everything up. I'm And we should have the, where's the cut list? So search for the cut list. Okay, so this is the format of the cut list. So the detection looks like this. So in the detection, what it does is it gives you a timestamp of each scene change like this. Okay, but this isn't a format that ffmpeg can actually use. So what I had to do was do a lot of maths and use awk, and I came up with a script that automates it. And what it does is it takes the detection file and sort of subtracts the second line from the first line and does some mad maths that I won't make your head explode with. But it will give us this format where now what we have is a start time and a duration for the clip. So as you can see here, at 15.75 seconds, we're going to create a clip that is 7.292 seconds long. So you can see this is all bang to the millisecond. Then what happens is the scene cut script will actually loop through these, and it will take the value before the comma, so that is the start time, and then the value after here for the duration of the clip. So the scene cut script basically goes through each of these lines, seeks to this position, and then creates a clip for this duration. So that's how that all works. That's how it basically chops up everything automatically. And again, we've got all those there. And if I was to run make input equals bbb, bbb.mp4, again, what's going to happen is it's going to run through first section, do the detection, then it's going to say, okay, I've already done this, I can stop. There you go, bang on cue, on cue, on cue. So as you can see, that's the advantage of the Makefile, is because it works on file modification times. It sees, okay, the file's already done, look, it's, you know, I don't need to do this anymore, so I'm not going to go through and chop the clip up because the clip's already there, as you can see. And so again, make clean. Do you want to move all those files? Yeah, I sure do. Bang. As you can see, we're just left with the Makefile and the original input file. So that's how we can automate ffmpeg scene detection, so that literally we just have to run a couple of commands, just type make or make input equals in the file name, and it's going to automate the whole process and chop up the video into all the chunks. And again, you can clean the directory with make clean. So that's the script. Again, input file, we run cut down here. As you can see, cut depends on time, time depends on detect, detect depends on input. So even though we're specifying cut, what it then does, it goes, okay, yep, cut, okay, I need to run time, time, okay, I need to run detect, and then it goes up to detect, takes the video file, creates a detection file, then runs on to scene time, takes the detection file, creates the cut list, moves on to scene cut, gets the video in the cut list, chops the video up, job done. Again, we've got the clean down here. Remember the phony clean option, because if we didn't have that and we had a file name called clean and we ran make, it would then run this command. So to prevent that, we prefix it with this phony clean option, and what that means is the recipe only gets executed when we explicitly run make clean. So that's how it all works. Again, all you got to do, either change this to the file name, or you just run make input tab, give it the file name, you know, you just press tab, and that's it. That's all you got to do, and it will chop the video up. Couldn't get much easier. Obviously you've got to install the scripts and everything first. So these are when GitHub eventually loads. So these are all these scripts. So this is a collection of scripts that I've written which use ffmpeg to do various things like combine clips, color correction, crossfade, extracting frames, normalizing, picture in picture, pan scan. Got the scene cut scripts here. Also got one called scene time, which is when you want to create clips that aren't all next to each other. I did a video on that, you can check that out. We've got scopes, which is basically like video scopes, like you get in DaVinci Resolve, or other video editors, you know, histogram, all that kind of stuff, using ffplay. Got thumbnails to create a contact sheet of thumbnails of the video. Got trim clip, which is used to trim a video or audio clip to the milliseconds. Got stuff for creating GIFs and WebP, waveforms, X-Fade, that's using all the ffmpeg transitions. So you can do crossfades and all that kind of stuff between clips, and zoom pan is like a Ken Burns effect. But these are all the scripts, and this is how you can install them, and there's a whole playlist on YouTube. So these were the original scripts I did almost a year ago, ffmpeg scene detection scripts. And again, it's just that you've got to execute them one after another, and I just wanted a way to make things a bit more automatic and a bit easier, because I'm lazy basically. And instead of typing out 3 sets of commands, I just thought it'd be nice just to be able to type make and just have the whole thing get automated and done for you. You know, that's what computers are for. And why sit there and type stuff in when you can get the computer to do it for you? So those are the original videos. These are the scripts. So I'll put a link to this under the video, and as you can see up here, these are all the scripts, and you can see the new file, Makefile scene detection, Makefile. So what you do is you come across in here, raw, just save this Makefile, put it in the directory, and run make. Either, you know, change that, run make, or, you know, make input equals and the file name. Press return, and it's going to analyze the whole video and chop it up all in one go. But that's all for now. And it was just a sort of way of sort of automating things and sort of, you know, reusing other tools to kind of do this. Again, you could, you know, create another script, but as I said, using a Makefile's got the advantages of, you know, it's, you run make again, it doesn't, you know, try and reprocess everything. We got the advantage of being able to run make clean and remove everything, clean the directory. So I think it's a really nice solution on how to automate stuff. So that's all for now, and I'll put links to all this under the video.